Hello everyone. For today's tutorial video, I'd like to introduce the concept of linear momentum, as well as revise Newton's second law and third law in terms of momentum rather than simply mass. Momentum is denoted with P because mass is already symbolized with M, and the P stands for a pater, exactly like with centripetal force. The equation for momentum is P equals m times v, and the conceptual, non-mathematical definition of momentum is also an object's tendency to resist changes in its motion, either in strength or direction, exactly like how it works with mass. However, momentum is more accurate, as for example, an object moving with a higher velocity or at a faster speed tends to be harder to slow down than an object moving at a slower speed, which mass alone would not explain. Therefore, Newton's second law can be more accurately written as net force equals change in momentum over change in time. And this is actually how Newton himself first wrote the formula. Force equals mass times acceleration is simply a more simplified interpretation of the law. It wasn't exactly like how he wrote it. This also means that an object with a higher momentum, as well as a higher mass, will transmit more force when colliding with other objects. For example, if you curl your hand into a fist, and make sure the fist is the same exact mass, or shape, during both experiments, but slowly put your fist on the table one time, and violently banged it the other time, you would notice the second time transferred more force than the first time, even though you used the same exact mass. In fact, every object has the same momentum, i.e. conserves it provided there are no external forces acting on it. This is formally called the law of conservation of momentum, and can be used to estimate what would happen in a collision. Since we know, by the exact definition, force equals change in momentum over change in time, we can rearrange this and state that a change in object's momentum is the net force times the change in time. This implies that when a harder object collides with a wall, it will experience a greater force and therefore will more likely break, owing to the shortness in time of the collision, whereas a more elastic object, like a volleyball, would deform more when colliding with the same wall at the same speed, so it experiences less overall force because it takes place over a longer change in time. The rearrangement of the equation to isolate change in momentum by itself is called the impulse-momentum theorem, as the force that causes the momentum to change is more formally called an impulse. However, one thing to note is that, generally, only forces at or very close to the center of mass of an object will cause a change in linear momentum, and all other places will instead cause the object to rotate, which is what we will investigate in more detail in the next tutorial, when I introduce you to the rotational version of momentum. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.